let me come on stage Luca Grementieri, that will talk about diffusion versus flow matching.
Hi, everybody. This talk is not prepared at all. So I wanted to reason with you about the differences between diffusion models and flow matching models. So I hope you have heard about diffusion models to generate images, or in my case, the case of my company, 3D point clouds. And in diffusion models, you start from your sample, you add some noise, and you obtain Gaussian noise, and you train a model to revert this process. Instead, in flow matching model, you start directly from a known distribution that is like a Gaussian distribution, Gaussian noise, and you match this distribution to a data sample. And you can train a model to go from the noise distribution to a data sample by training a neural network the correct displacement that brings your starting noise point toward your sample. And if this model is trained, you can then follow this incremental deformation to reach your data distribution. So both two kinds of models can be used to go from noise to a data distribution, performing an iterative process. But I want to highlight here that in the real world, usually the task is much more constrained. Usually we know something. We don't want to start from noise. For example, in the case of my company, we are trying to generate fake teeth for replacing unhealthy teeth. And in that case, we already have some knowledge about the shape of a teeth. We don't want to start from noise or Gaussian noise to create a continuous and smooth surface. So for example, we could start from a cube, or maybe we could start from a tooth that we have already scanned, or a template. And so I want to point out that the flow matching models have this advantage over diffusion models, that they are not bounded to start from a Gaussian noise, from a noise distribution. For diffusion models, you cannot avoid to start from Gaussian noise, because the point of the diffusion process is that it goes from the data distribution towards the Gaussian distribution by corruption, and then the model is trained to revert the process. Instead, in flow matching, there is no constraint on the initial distribution and no constraint on the end distribution. So it is very interesting kinds of model to do generative AI in more constrained settings, where you have some knowledge that you want to use as a starting point. And so this is the main message. Take a look at flow matching models instead of diffusion models. And there are some nice libraries available to do that. I'm not involved into that, but I think it's cool. Thank you.
Thank you, Luca. With 40 seconds to spare. So next up is Andrea Saltarello, who will talk about AI as a means of inclusion. Thank you, Andrea.
Thank you, Pietro. I want you all to know that I'm here just because he asked me to do this, okay?
I'm the pusher.
He's the pusher, okay. My dad, okay, I only want to share a story with you. My dad was deaf, okay? So that he couldn't hear, and he couldn't hear because he had his anvil and stirrup removed. Okay, he went under surgery because of acute otitis to both ears, okay? First year, he was 27. Second one, he was 29, okay? And that is a person who were able to both talk and speak suddenly couldn't hear anymore, okay? But, and I was a child, okay? But I could talk with my dad because he had bone conducting watches, okay? That is, glasses that were capable of capturing the waveform, okay, we generate when we speak. But I could only talk with him if there wasn't noise, okay, background noise. Otherwise, the watches couldn't work properly. Okay, and such piece of technology inspired a child who wanted to become as good as he could to mastering technology. And a few decades later on, today I am actually from 2020, okay, I am data science professor at Politecnico di Milano, okay, and I have been organizing the AI Conf, which is the longest established AI-related conference in Italy since 2019. And what inspired me, okay, was that little piece of technology, okay? And nowadays we have AI, we're in the AI era, okay? So we have Luxottica, which last year released the Luxottica Nuance, which runs small models on the glasses in order to remove noise, okay, and make audio more audible to people who has some kind of hearing impairedness, okay? And we have the Meta watches, which, okay, I know that for customers, they are all about taking pictures to have them posted on Instagram. But a nice feature that those watches support is a look and tell feature. And I urge you to go to YouTube and look for blind people using them to ask the watches, hey, Meta, look and tell me what's on my screen, okay, the laptop screen, to understand, okay. And actually, due to a remote inference, okay, we have high latency, but we are in the NPU era. So we are now capable of running models locally, okay, and it will take maybe a couple of years to have models run locally by those watches. Okay, so what I want you to know that the technology, the products you work on today might be of inspiration of a child who sometime later on will try to do their best to improve people's life. Thank you for listening.
Thank you, Andrea. Thank you a lot. Next up is Alexei, who will talk about the OSS AI knowledge stack, OAKS.
Thank you so much. Thank you very much for having me. Thank you, Alessandro, for inviting me. I'm a huge fan of Italy. So, I accept LinkedIn requests. I reject all the spam requests, but if you have an Italian name, I will always accept it. So send me a LinkedIn request. I love it. Great open source AI community here. So about myself, I'm an AI community architect at Neo4j, which is a graph database company, and it's been one of the actually oldest graph database companies. But last year, we suddenly found ourselves in the middle of Gen AI with GraphRag. Who heard about GraphRag? A lot of people, right? So GraphRag basically using graph knowledge base to dehallucinate LLMs, right? You ground truth LLMs, and so I think people found that, because LLMs lie, you need some kind of knowledge representation which is distinct from LLM. And LLM is not a source of truth. LLM does not generate knowledge. LLM generates a sequence of tokens, right, which you kind of decide whether it's meaning or not. So we decided to do this project called OAKS, which is open source AI agentic knowledge stack. You can read it however you want. So basically using knowledge graph for multiple purposes. First of all, with agents, knowledge graph is the most natural way to have AI memory, right? Agents go into the world, they do something, they need to update the state of the world. They need to store the result of their work somewhere. So you see recently all these AI memory companies popped up, right? And so they provide different ways. But if you think a knowledge graph is the most natural way, something which we know very well, since semantic web, we develop mechanisms to represent, validate, and use knowledge graphs. So OAKS is a project for collaboration. We invite folks to basically map yourself if you're open source AI. Are you doing structured extraction? Are you doing structured output? are you doing knowledge transformation, right? So it's kind of a map, but also it's interoperable kind of group of folks who figure out ways to collaborate. And so our latest addition, we're building a knowledge graph of all MCP servers, right? They popped up everywhere. It's very hard to figure out which one do you need. So we use cross-SAN, which is a new standard from ML Commons, and its latest extension called semantic cross-SAN, which is basically ontologies, and it's a collaboration with Royal Dutch Academy of Sciences, IBM, Neo4j, and some others. So if you're interested in knowledge and how to use it, and if you also have an MCP server and you want to kind of add yourself to the knowledge graph, please find me. I'm chief scientist. I used to be a chief scientist. So it's @chiefscientist on Twitter, on LinkedIn, on Instagram. I'm a chief scientist everywhere on Telegram, so you can Telegram me. So find me, add yourself, and hope to collaborate with your open source AI project in the future. Thank you.